All right. Well, I think I'll go ahead and get started, and others join. They can always come in. So, thanks for joining us. This is number 2 in what we hope will be a regular series of webinars about PAC products, testing that we've done, new products coming out, just different bits of information on installation um, related to fire and acoustical performance and all kinds of different things. So for those of you who don't know me, I am Mike Raley. I am PAC's acoustical engineer, joined PAC in January of this year. And I help with PAC's acoustical testing and tech support, answering questions, and just all kinds of different stuff that I can get my hands on. So today, our topic of discussion is a new PAC product. It is the RSIC, the RSIC-SIX. And we're going to talk specifically kind of about low frequency noise control, which is an area where the SIX shines, provides some advantages over products that are already on the market. So we'll kind of dig into that, talk about the product, its acoustical performance, and then also installation and other details about it. And as I said before, there's a chat in here. Feel free to, if you've got any questions that come up as I'm going along, type your questions into the chat. We can track those and then make sure we get to them at the end of the presentation. But we will save questions until the end of the presentation just to kind of help the flow. And with that, we'll get started. So wood frame construction is the most common construction for multifamily housing units. So in 2020, from US Census Bureau data, 70% of all multifamily units were wood framed. There's a higher percentage for rent, and lower percentage for sale units. But even still, for sale units, 46% of them were wood framed. And in wood frame construction, also other lightweight sort of flexible construction like steel joists, C-section joists, open web trusses, things like that. They're lightweight and they're often fairly flexible. So low frequency noise control becomes especially problematic in those structures. And low frequency thumps, thuds, those kinds of things are typically the primary source of impact noise related complaints. And impact noise related complaints tend to be the biggest issue for noise, one of the biggest issues at least for noise in those kinds of buildings. And it's historically been a pretty difficult thing to address. So typical construction for these might be an 18-inch open web truss. You'll have some sort of acoustical underlayment, a gypsum concrete topping. And typically for the ceiling side, you'll have your acoustical isolation from resilient channel and maybe 1 or 2 layers of gypsum board for the ceiling. And this can get you pretty good STC ratings into the mid to high 50s, maybe low 60s. And the IIC ratings, you can get low to mid 50s, something like that with hard surface flooring. But the IIC ratings don't necessarily tell the entire story either. They don't necessarily take into account those low frequency thumps and thuds that often become the biggest issue. Carpet and pad has historically been the way to get, better IIC ratings in lightweight wood construction or in, concrete construction as well. And you can get very high IIC ratings with carpet, but even with carpet and pad, those thumps and thuds can still be an issue. And, even at your own home, walking around, like, my house is single story. I've got carpet and pad in some areas, but it's got a crawl space, so it's still an elevated structure. And just walking around, like, I can hear those thumps and thuds just radiating from the structure up. Obviously, I don't have anybody downstairs below me to worry about, but you can still hear that sound from walking around on that structure. So carpet, will come up a lot of times. It's often used in bedrooms. There's a lot of condo associations that will, say you have to use carpet, especially in bedrooms, to try and address that noise. But some studies and testing have shown that carpet can actually increase the amount of low frequency energy or low frequency noise in lightweight wood structures. There's a big paper by Blazer and Dupree that's often referenced in this kind of area, and they showed there that at especially low frequencies, the carpet could actually increase the amount of low frequency energy. So get into some data here, show some different things, right? So those of you who aren't used to looking at these kinds of graphs, here on the bottom we have frequencies. So from low frequency on the left to high frequency on the right. So you can think about it as sort of like the keys on a piano or something like that, right? You go up in frequency or up in pitch as you go to the right. And then on the left, on the y-axis, we have the impact sound pressure level, so how loud it is at these different frequencies. Right, so the higher up it is, the louder it is. So when we're talking about impact sound, we want to see things lower down on the graph. Something goes down, it gets quieter or better, right? So typical construction, I've just got 18-inch open web truss here, right? Fairly standard. So bare is here. You see that it's pretty high impact sound levels for a broad frequency range, and then eventually at the highest frequencies it sort of starts to trail off. And when you add a wood underlayment, a wood flooring and an underlayment, right, you can reduce these higher frequencies by quite a bit, but you see nothing really happening here at the low frequencies. Right? So you get this big shift down here, but no change at the low frequencies. When you add carpet, you get a dramatic reduction at most frequencies, but at the low frequencies, you still don't see much change, right? And sometimes, as I mentioned from the Blazer and Dupree papers, you can actually see the low frequency levels go up. So that becomes a challenge. Concrete is a totally different animal, right? Concrete is heavy, it's often much stiffer, and so low frequency thumps and thuds typically aren't an issue in concrete structures. That's generally true for post-tension slabs, things like that, like 6-inch and greater concrete slabs. But that's not always the case for lighter weight concrete structures like composite metal decks, either like long span composite metal decks or shorter span corrugated metal decks on steel open web trusses or something like that. Those can have some of those low frequency issues as well. But this is why typically in high-rise buildings, whether it's hotels or it's apartments or condos or something like that, you don't tend to have those issues with low-frequency thumps and thuds. You can use flooring and underlayment to get rid of the mid and high-frequency energy, and you can get pretty good, not just IIC ratings, but also perceived impact sound levels in the spaces below. So just as a comparison, right? So in the blue, we have this typical open web truss with just bare gypsum concrete for easier comparisons here. Take flooring and underlayments out of it. So because of the wood and the isolated ceiling and things like that, you actually have better impact sound pressure levels at high frequencies, this range highlighted here in blue, but at low frequencies, the concrete does considerably better. And the high frequencies are a lot easier to deal with underlayments, flooring, other additional ceiling isolation, things like that. The low frequencies are a lot more difficult to take care of. So here you can see, right, with carpet, big differences, mid and high frequencies, even going down to 100 hertz. And it's better than the bare concrete. Obviously, the concrete you could improve by putting carpet on it too. But the low frequencies, even with the carpet, right, the open web truss is still a fair bit higher than the concrete. So the challenge has always been, how do you provide low frequency performance, good low frequency performance in lightweight wood structures, or just lightweight joist and truss structures? Increasing mass and stiffness of the structure is one way to do that, right, to try and get it closer to concrete, but that's often not feasible because of cost and the complexity and just all the other restraints that go into those assemblies. So other options have been, typically one way that we would get as acousticians, we would get better low frequency isolation in these structures is to use 1-inch deflection spring hangers. And these work well, they provide a great deal of isolation, but they're also tend to be pretty expensive. I mean, they can be more than $40 a piece. And there's also additional labor associated with these because there's multiple layers of framing that go into them. So you have a cold roll channel that inserts here into this between the C-clip and the threaded rod, and then on below that cold roll channel, you attach hat channel, and then your gypsum board ceiling gets attached to that. So there's additional materials involved, and there's additional labor involved, and so they tend to be pretty expensive, and therefore only get used in, very high-end spaces and critical applications and things like that. So the alternative now is the SIX, right? So the SIX sits in this nice middle ground between a 1-inch deflection, full spring hanger, and things like the RSIC-1, the rubber clip that's been out for many years and works really well to provide acoustic isolation. So the SIX provides a 1/2 inch of deflection, and it's half the total installed cost or less of a typical 1-inch deflection spring. It's easy to install, just like the RSIC-1, right? So you just screw it to the bottom of your structure and you snap hat channel into it and you're good to go. You don't have these additional layers of cold rolled channel and all of these things that you have to deal with installing. And it is included in a number of common UL assemblies. Right now it's in, I think, 12 different UL assemblies, and I'll list those later when I go into more details. So look at the acoustical performance of the SIX, right? So here's a test done on, again, the standard 18-inch open web truss. We've got a 3/4 inch gypsum concrete poured direct onto the subfloor. So there's no other sort of acoustic isolation in this assembly other than the SIX. And you can see here in blue, here's a 6-inch concrete slab, bare concrete slab. Now, obviously, the high frequency performance is, you've got high impact sound pressure levels there because it's a bare concrete slab. But really what we're interested in is this low frequency here, because that's really the problem. And we can see that here in the green, this assembly has low frequency impact levels that are comparable to the concrete and actually a little bit lower at 80 and 100 hertz. And so for those of you that are going to ask about this comparison and the reliability of comparing low frequency data from a lab. So this data, everything that I'm presenting here is all data that was taken at Intertek's testing facility in York, Pennsylvania. And all of this testing was done usually within the same year. These tests that were compared here were done within like a couple weeks of each other. So it's the same lab, same receive chamber, same microphone placements and all of those kinds of things. So as many variables as possible have been controlled and kept the same in here to make this as good of an A/B comparison as we can get at these low frequencies in a lab space. So, and then the orange you see is the 6-inch concrete with a wire hung ceiling. So even concrete with a wire hung ceiling, the SIX brings an 18-inch open web truss into the same level of performance as that. Then if we really want to get crazy, then we can start adding isolation to the top side, right? So we've played around with that too. So this is more of a high performance floor system or subflooring system where we've got a 3/4 inch Maxon Acoustimat Premium underneath 1.5 inches of gypsum concrete. So we've got a significant amount of additional mass on the top side and isolation there. And even in a bare assembly, we've got an IIC-62, so no flooring or underlayment here. And we're already in sort of typical condo level performance. And you can see that the low frequency performance is actually better than the 6-inch concrete slab with a wire hung ceiling. And if you put flooring and underlayment on top of this, you'll start to roll off some of these mid frequencies too and get even better performance. So the installation of it, like I said, it's very similar to the RSIC-1 that many people are familiar with. It uses 25 gauge drywall furring channel. So there's no cold channel like you usually have to use with 1-inch deflection springs. So there's lower material and labor costs associated with that. It installs direct to the other side of the joist, just one screw goes right in. Don't need a laser level to set the ceiling height like you might need with full 1-inch deflection springs. Just adjusting it, make sure it's level. There's less deflection in the springs, so there's less variation in the ceiling, and also there's just less, you don't have a threaded rod like you do in those springs that you have to adjust to make sure everything's level. So it's just much easier installation, a lot lower labor costs. It's a typical 16-inch by 48-inch spacing with 2 layers of 5/8 gypsum board, again, similar to the RSIC-1. And it doesn't require vendor supplied spring layout like 1-inch deflection springs do. This would be for a typical ceiling, like if you're putting in a condo or something like that, where you have very uniform loads. If you're getting into a situation where you're going to have, more concentrated loads or something like that, we could of course provide spring layouts for those. But the point is that for typical applications, this is a much simpler installation, a much simpler application, but it still gets you very good acoustical performance. Like I mentioned earlier, for fire ratings, it's already included in 12 UL fire rated design assemblies. So we've kind of, tried to put it into sort of the greatest hits, the ones that we see the most common. So we've got open web truss, we've got 5 of those. Wood I joist TJIs, we've got 3 of those. Solid wood joists, we have 3, and we have 1 steel C-section. So that should cover a lot of the bases. But if you're interested in this and you're looking at a particular UL assembly that it's not shown here, reach out to us and we can have that discussion. Expected release date. I've had a lot of people asking me as I start talking about this, like, okay, this is cool. Like, when can we get it? So we're getting pieces coming in very soon. They should be on their way, and this should be available September. So just in a month and a half or so, we should have these ready to go. So future versions, right? With the RSIC-1, we have a bunch of different versions of it. It uses the same basic clip, provides the same level of isolation, but we just have different sort of metal brackets that allow it to be installed in different ways for specific applications. And we'll do the same thing, sort of similar versions of the SIX. So we'll do the adjustable direct mount that would allow you to mount it beneath a concrete slab to provide an isolated ceiling, but get a very small plenum space, somewhere in the 2.5, 3 inch range, maybe minimum, depending on exactly how the dimensions work out. And I was just talking to a consultant friend yesterday about using this for the ceiling of a generator room, right? Where there's apartments or maybe hotel rooms above it, and you need higher levels of sound isolation between those spaces. A low profile side mount. This usually is would be a non-fire rated, so not something that you would use in multifamily construction. But with the RSIC-1, we see these used a lot in residential spaces. Somebody's doing a home listening room or a home theater or home recording studio or something like that, and they need to maximize their ceiling height, but they don't have to meet a UL fire resistive design. And then the last one would be the EXT04. So this would be something that could be used to drop a ceiling lower, maybe for MEP clearances, or also to help level a ceiling so you can adjust the height of the clip. So if you're working on like an old warehouse retrofit or something like that, and you have a ceiling that varies considerably, it's not at all level, you could use this to get your ceiling level and provide a high level of acoustic isolation. And that's pretty much it. So now just turn it over for questions. We've got contact information here, so feel free to contact us if you think of other questions or anything like that. And I also will just give a quick plug, like some of the acoustic data that's in here that's mentioned. A lot of that testing is available if you go to PACInternationalLLC.com. We have our online test database where you can go through and search for different assemblies and things like that and get information on those and do some comparisons. And I think it's a really handy, useful tool. So I see in the chat, we've already got one question from Francisco. What was the ballpark price per clip for the SIX? Mike Gernhardt, if you're there, I'm going to let you hop in and answer that one. I don't want to speak out of turn, and I'm not
sure.
the price guy.
Sure, I was just pulling it up now, and a cash retail price be around $9. Obviously, your wholesale pricing is going to be somewhere below that. That's what we expect the retail market to hit at, is around $9 an isolator.
All right, thanks. All right, other questions? Noral, I know you had several for me.
Well, yes, this is the obvious first competition we've seen for one product that's been out on the market for a few years that needed some competition.
Okay.
Sounds like it's right in that ballpark of aimed at doing better at the low frequencies.
Yes, that is the
without
goal.
going to the heavy coil spring.
Yes.
And such. And so we certainly welcome this. And one of the issues that's come up with the other product in my situation recently was a client who could not use it because they discovered that they could not fill the cavity with any kind of absorber. And in their situation, if they didn't fill the cavity, they had to put sprinklers in the cavity. And that other product would not allow them to fill the cavity.
What was the structure where they were trying to fill the cavity?
It's a wood frame, wood truss.
And they wanted to, was it that they couldn't fill the entire joist cavity with insulation, or that they
That's
couldn't
right.
put any?
No. They could put it in there. The other product allows specifically 3 to 6 inches, I think.
Mm-hmm.
Or maybe 3 to 5.5 or something like that. There's a specific range that is allowed. And it does not allow filling the cavity. And if you look at the various UL listings for various truss assemblies, some of them allow you to fill the cavity, some don't.
Mm-hmm.
And some where they don't allow you to fill the cavity, various manufacturers have in some cases gotten special letters or whatever that say, yes, you can, etc. In this case. But in the case of that other particular competing product, which does not have a UL listing, but one of these ESRs or whatever.
Oh, yeah, the ICC ESR reports.
It specifically says a range of absorber, and though the manufacturer tried to say you should be able to fill it and so forth, they could not get the local authority to agree. So
right.
they had to drop back to a rubber isolation clip because they couldn't afford the 1-inch springs because of that. And was disappointing.
Yeah, I can understand that.
So that's something, if you haven't thought about, you need to think about. Where this comes into play is it's the NFPA, National Fire Protection Code, Type 3, I think it is, or 13. The full 13, not 13R. There's a 13 residential. 13 residential, you don't have a problem.
Right, yeah, because the residential codes and requirements are different than the commercial ones, which multifamily falls under.
You got to meet the full 13, which they did. Then you either have to fill the cavity with fiberglass or mineral wool, or you have to sprinkler it.
Correct. Yeah. So, and I'll let Mike jump in here on this as well, but just, so generally, me coming into PAC, I have learned an awful lot in the 6 months that I've been here about fire. And I would just say that fire resistive designs is and all the ins and outs and intricacies of that Norrell is getting into is an area where PAC has a lot of expertise. PAC has done a ton of UL testing.
More than me or you.
Well, far more than me, for sure. I mean, I can talk about acoustics and the details of that, but fire, I'm learning. I'm drinking from the fire hose, but as it were. But yeah, so I know that those are conversations that we've been having here and things that Mike and Elzo have really been looking into. So but generally speaking, yeah, a lot of times, even with resilient channel and a lot of the typical UL design assemblies, you're often limited to 3.5 inches of bad insulation, or if you go thicker, you have to reduce your channel spacing, which, as you well know, Norrell, can create other issues acoustically. In terms of the UL assemblies that the SIX is already listed in, Mike, I'll let you jump in on this. But one of the things is the number of ceiling gyp layers that you have, right? Like if you go for a lot of those assemblies, you require just one layer of 5/8 Type C to get your rating, and when you add an additional layer, which is what we would, what the SIX is sort of based on, right, for the additional loading and mass and things like that for the assemblies or the market it's going into, that can allow you to do some other things within those UL assembly provisions. But I'll let Mike or Elzo, if he's on here, chime into the details of that.
Yeah, I'll go ahead and take it. Norrell, thank you for that question. It's something that we see overlooked quite a bit in the world of acoustics, unfortunately, is the ideal acoustic plan may not reach the necessary fire requirements. So to address your question, yes, just like in the ICC or ESR reports, a lot of UL assemblies will have a handicap on the amount of fiberglass or rock wool or cotton, whatever you want to use in that cavity. They will have a restriction on the total amount. The reason being is that more insulation holds more heat at the gypsum board, forces it to fail sooner. That's the short answer of why there are handicaps or limitations on fiberglass or mineral wool. So a requirement to fill the cavity would probably be aimed towards smoke migration. So the smoke can't get into the cavity and travel horizontally through that cavity and creep into other areas or whatever it needs to do. We see that in walls, a lot of times in wall systems where you have to fill the insulation from gypsum board to gypsum board, or you have to put in horizontal blocking so the smoke can't go up the wall like a chimney and go into the ceiling cavity. With that being said, we designed the SIX, and through our UL development of the product, tried to mimic or mirror the RSIC-1 as close as possible from a UL standpoint, to give us those same flexibilities that we have with the RSIC-1. Also, another reason why we chose certain UL assemblies, some or most of those assemblies, we chose them because they gave us that flexibility, exactly what you were discussing, either multiple layers of gypsum board and or variations on cavity thick or insulation thickness in the cavity. As you were talking, I pulled up 4 reports. 3 out of the 4 do have a handicap or a limitation up to roughly 6 inches of fiberglass. A couple of them, like M502, you can fill the cavity, it doesn't matter. So it really depends on how that system was lit on fire and burnt as to what it will or won't accept. But with that being said, again, we aimed this at the RSIC-1. So if all of our ducks are in a row correctly, we should be able to get every assembly that a RSIC-1 is published in. We should be able to get the RSIC-SIX also published in that assembly. But there's some monetary concerns that come with getting 150 UL designs. So we cherry picked the most common versions that we see, and that's where we're at now. So to answer your question, we've run across the same issue that you ran across with the springs with the RSIC-1 in a specific assembly that didn't quite meet the criteria that was necessary for the local jurisdiction. Unfortunately, because we're national and you work all over the nation, we try and use a blanket approach and get the most common versions, and it doesn't necessarily mean that each jurisdiction will follow or accept those generalizations, if you want to call it that. I hate to use that word, but that's what it is. To answer your question, we try our hardest to avoid those problems, and we'll follow that same rule with the RSIC-SIX.
Yeah, well, there are some assemblies out there, as you mentioned, which do allow you to fill the cavity with say resilient channel or with the RSIC-1 and so forth, and such. So it's possible with picking the right assembly to fill the cavity. And unfortunately, this other product was not on any UL listing. It was just covered by that ESR, and the ESR specifically limited the thickness of the absorber, so they were stuck.
Yeah. Hey, Mike, can you bring up the fire rating selector? Sorry, Nora, I didn't mean to jump in there. And bring up the SIX.
The fire selector on our website?
Yes, please. And bring up the SIX in the fire rating.
Yeah, bear with me for a second. Where is the... So let me switch screens that I'm sharing here. All right, so is this what you're looking for, Mike? Is the selector here?
Yeah, so Norrell, I just clicked on the first 4 assemblies, and 2 of them allowed for full cavity fill of insulation. They did, mainly because they were already 2-layer systems. When you get into those hurdles where you have a handicap on the amount of insulation, a lot of times we'll see a single layer of gypsum board get you your 1-hour fire rating. And that's where you run into some let's call it marginal fire ratings. I hate to use that term also, but a marginal fire rating would be something that just made it. Now, granted, every fire rating or every fire test you turn off as soon as you make it because it's expensive to keep the torch lit. With that being said, so those systems, you should be able to add a second layer of gypsum board and then put as much insulation as you want in the cavity. Obviously, the local jurisdiction will have the final say on that. So it's about, some of it is about making sure that the local jurisdiction has all the information they need. And that's where we somewhat excel, in the fact that we know how to package those up together and have a conversation with the inspector to make sure they understand what the UL guideline says and that we're all on the same page so the project can move forward.
Yeah. Well, I think the architect in that case was going by that kind of experience that often you could, if you have a second layer of gypsum, you can fill the cavity. And unfortunately, since this particular other assembly was not on any UL listing, just on the ESR, and the ESR was very specific, even with 2 layers of gypsum,
Right.
they couldn't get around it.
Okay. Yeah, it happens, unfortunately.
Yeah, I've seen the ESR, those reports be much more specific, and the UL assemblies, I think, have more leeway, and also within the general provisions and things like that, there's a little bit more flexibility there. And also the fact that, we're already in, 12 different ones, 5 different open web truss assemblies, and my guess is that will expand as time moves on. So there will be more ways to get the assembly that you want and also get the fire rating.
Okay. Another question, another subject on your assembly, on the clip itself. Does it have a rubber element in it in addition to the spring?
Yes, it does. It has a rubber element. So I've got a little piece here. So I don't know if you can. Oh, the background's gonna just hang on a second.
Yeah. So Normal, there's a rubber bushing at the top that mounts into the claw portion. Then there's a rubber bushing at the bottom, for lack of a better description, a washer, to make sure that we don't have any metal to metal connection. And internally there is a sleeve that makes sure that it helps center the spring, to make sure the spring stays centered and doesn't tip, and also helps decouple or separate the spring from the center ferrule. And this clip is a little longer. The ferrule is longer than our standard RSIC one. So we did that so we could add all these extra parts to make sure that we had plenty of buffer around that spring to keep it 100% separated.
And with the rubber elements in there, that I would expect, give you a little improvement at higher frequencies, where some higher frequencies might get through the metal spring if you did not have the rubber.
Correct.
Yes, sir.
So forth. Mm-hmm. And that gives you some advantage at the higher frequencies over something that's an all metal system.
Yes, I agree, and I don't have any data to back this up, but I'm also curious about how this wave spring compares in terms of like spring surge frequencies and that high frequency transmission relative to a typical steel coil spring. I think because of just the shape of the spring, the way the coils are, there might be a little bit more loss. It's also a flat ribbon rather than a round wire. There may be some things there that play, but we haven't done spring specific testing or anything like that, because ultimately what matters is in the actual assembly how it performs. Any other questions, either Norl or anybody else?
I think everybody realizes it does require 2 layers of gypsum probably to get the proper deflection on the spring and everything.
Yeah, it's designed for 2 layers of 5/8 Type C, really. I mean, Type X, there's not a huge difference, but most of the fire resistant designs are going to require Type C. Well, that's not necessarily true, but we typically will say Type C. And it does weigh a little bit more than the Type X. You could do a single layer, but if you're going to, use something like this, you're typically going for a high performance design. So 2 layers is what makes sense.
Bring up
Norl,
the Type C.
Go ahead.
Go ahead, Mike.
Well, I was going to say that you're right. The clip was designed for 2 layers of gypsum board. one of the secondary goals of this is to not have additional engineering involved in the product like you currently have for your coil springs. As you know, you have to lay out the ceiling, and then you have to make changes for adjustments in joist spacing, a beam, a soffit, all of those other items. You have to account for those and move the products around to facilitate that layout. The goal with this is more of a RSIC-1 type layout where standardized spacing, 16 by 48 ounce center, holds 2 layers of gypsum board. That's what we want this to be as a standard. Any variations from that, we'll get involved on the engineering side, obviously, working with the acoustical engineers and or the owners of the project, whether it's the contractor or the GC or whoever it is, to make sure that things aren't wrong. But the goal of this is to have less time spent before you get to implement the product. Sometimes some companies are pretty long out. We try and be pretty quick. We're usually a couple days on our side, as long as we have all the information we need. This is aimed, like Mike had stated before, more of a commercially viable and a condo project, maybe is a better way to put that, where there's some uniformity in units as you move across this. You know, maybe we're only doing the amenity spaces where you have, or not the amenity spaces, but the units that have those common spaces, like in the roof. You know, maybe you use RSIC-1s for the rest of the ceilings, and you use this and that particular area because you know that that's needed in that area. Ideally, we'd like to sell it on the whole job, but we understand that the price point will convert that at some point throughout projects. But the end goal, or the beginning goal here, is to make sure that it's as simple as possible. The layout's standardized. It's very similar to a RSIC-1 layout so that it's understandable for all parties involved and can be implemented without a lot of front-end work.
Yeah. The difference between this and the RSIC-1, though, is that we do have 3 different spring stiffnesses. So you can see here in this sort of sample layout, right, that there's whites at the corner because they're carrying like a quarter of the typical load. There's blues at the perimeter that are carrying a half, and then the reds in the middle area in the field carry the full weight of the 16 by 48 inch spacing. So we do have 3 different ones to maintain uniform deflection, both just to give a smooth ceiling, you know, because you don't want your ceiling, you know, coming up at the edges because you're getting less deflection because the springs are underloaded there, and also to maintain the level of acoustic isolation across the ceiling. So there are different stiffnesses of the springs.
Something you mentioned a while ago, Type C gypsum. I'll just bring something up. You might want to look into it. I haven't had a chance to verify this yet, but I have been told one of the major manufacturers has stopped making Type C. And
that is something
trying to get people to use lightweight gypsum instead.
That is something we have been talking about a lot, preparing for that change coming down the pipeline. And I have been in conversations with my sort of acoustical counterpart at that gypsum board manufacturer, talking about the differences between it and kind of how we address that. And it seems like from an acoustical standpoint, there's not necessarily a uniform delta in the tests that they've done. In some tests, they've seen the lightweight gypsum board actually perform slightly better than their, and they've tended to do like back-to-back comparisons. They're not comparing to tests that they did 10 years ago. Like they're going into the lab and they're testing both side by side. But in other instances, the lighter weight does, you know, a few points worse or a couple points worse or something like that.
Where I have the greatest concern is these low frequencies.
Yes.
I have a feeling there will be a consistent difference there.
I think that you're probably right. And it'll be interesting to see that, and we're talking internally about how we address that, and you know, obviously our historical testing going back 20 plus years now deals with the typical Type C primarily. So the change in weight, the move to the lightweight gypsum board is something that we're talking about. How do we address that, and you know, account for it in our testing, both old testing and then moving forwards. So yeah, that's good point, Norrell, and we'll keep looking into it, and we'll let you know. You'll probably start seeing some tests from us that have the lightweight stuff in it as it starts to come out more. But yeah, we've also been told by the lab that they have been notified many times that they won't be able to get the Type-C anymore. So it seems like pretty soon we're not going to have a choice, or we're going to have to get it from Type-C from some other manufacturer. Anything else?
I think that's it.
All right. Well, thanks everybody from joining us. I will just stick the contact info up here one more time, just in case. Yeah, feel free to reach out to us. Again, check out the test database online at pacinternationalllc.com, and yeah, we should have these available pretty soon. Thanks again, and stay tuned for presentation probably next month.